So like I said, today is segment and angle addition. And this is something that is quite logical. You probably already know this. You've probably already learned part plus part equals whole. Does that sound familiar to you?
No.
Some of you, okay, yeah. All that it means, yeah. All that it means is if you have something that has been broken up into multiple parts, the part, when added to the part, is going to be equal to the whole, right? Part plus part equals whole. Now, before we apply this to segment and angle addition, there are two vocab words that we need to review first. The first is a midpoint. So under this midpoint tab, you have midpoint. Under the midpoint tab, it says, a point that cuts a line into two blank parts. Oh, equal. Two equal parts, right? Midpoint means middle. Whenever you see the word midpoint, instead of using part plus part equals whole, you can use part equals part. So, on this example here, we have M as the midpoint of XY. What does that mean about our line segment? M is the center, good.
The middle of X.
It's the middle, good.
It's the midpoint of X.
That's literally
What more information do I now know?
Equal, the two equal.
Oh, what can we call this first part of the segment? Line segment XM is what?
Equal to line segment MY.
Beautiful.
wow.
XM is equal to or congruent to MY. How do I mark parts congruent?
Or it's
The equal squiggly.
So am I just going to do this? Does that look good to you?
You put X, line segment XM is congruent to line segment.
I could write it out, you're right, as a statement. However, there's a way to mark on the line that these are congruent. Yes.
You just mark it on the line.
How?
You wait.
Line.
Just put a line in the middle.
Oh, you're right.
Like a
The little dash.
Oh,
the tick mark.
the tick marks. We mark parts congruent with tick marks, right? Remember? What?
This is a line in the middle.
Really? Oh, I didn't understand. I didn't understand. Remember we went over that in geometry terms when we were marking the parts of the triangle congruent? You mark, okay. You mark parts of the line congruent with tick marks. So now this tells us XM is the same length as MY. Next, we have bisect. What does bi mean? What does sect mean? To sect something. Cut. Sect is another, I mean, it's not, it's just, it means, when it's in a word, it means cut. So to bisect something, what do you think that means?
Cut into two parts.
Cut into two equal parts. They're actually equal. So here, cuts a line into two equal parts. Does anyone see what the difference is between midpoint and bisect? Good. It doesn't necessarily have to be a point. Also, bisect is a verb. You can bisect something, right? It's something you can do to something else. It's a verb. And midpoint is a noun. It's just the name of a point in the middle. All right. So now, F bisects XY. FY is 6 long. Find XY. So what does F bisect XY tell us?
Yeah, they're equal.
Yeah. So what can I draw on them?
Tick mark.
My tick marks. XF is congruent to FY. And it tells us FY is how long? 6 long. So what else do I now know? Is what? It is also 6. And we were trying to find the total whole length. And what is it? How did we get that? Oh, you just added part plus part to get the whole. So here, xy is 12. Okay, so now on your other foldable, we can actually get into segment addition and angle addition. Now, segment addition is used when a segment is made up of multiple parts. When it's made up of multiple parts. So anytime you have a line segment, like we have here, and there is a point between the two endpoints, we are probably going to use segment addition. So on this problem, it says, solve for the length of xz. Now I'm going to kind of overanalyze this because it's easy. It's easy for us to understand. However, if I overanalyze it now, it'll be easier to apply to harder problems. So on the slide segment, how many parts do I have? 2, right? I have this xy first part, and then I have this yz second part, and together they add up to be the what? The whole. When we have multiple parts in a whole, what equation are we going to set up? At the top, what did we say?
Part plus part.
Oh, the part plus the part equals the whole. So our first part is how long? Our second part is how long? And our whole, therefore, is how long? 35. So xz is 35 long. Oh, because I wasn't thinking. Thank you. Whoops. Thank you. Part plus part equals whole, not part plus whole. All right, so now let's apply this to a slightly not really harder problem. Solve for AC. I have a line segment that has been broken up into what? How many parts? 2, right? So I know that my part plus my will be my good. So this is my first part, this is my second part, and this is my whole. So part plus part equals whole. What is the polynomial for my first part? 3x plus 2 plus, what is the poly for my second part? And what is my whole equal to? What do you think I'm going to have to do from here? Solve it. Yeah, I have to use algebra.
Great.
Great. So, what is my first step?
Combine like terms.
Simplify, combine like terms. So what are my like terms? So 3x plus 3x is? 2 minus 4 is? And then what should I do? So I'm going to subtract 4 over. And I'm going to add 2. So I'm left with 2x equals, and then, and x is beautiful. Hold up. Am I done? Why am I not done? Yeah, what did it originally ask of me? Solve for AC. So, what is the expression, the polynomial for the entire AC? 4x plus 6 is what AC is equal to. So what am I going to put in for x? Yeah, I just spent all that time solving for x. What is 4 times 4? Plus 6. So AC is 22 long. That's my answer. Any questions? Is this hard? No. Is it long? It's like medium. Medium length, yeah. All right. So now, angle addition. Same exact thing. What do you think the only difference is?
You're using an angle.
You're using an angle, and therefore, what do angles have? Oh, angles are measured in degrees. And there are symbols or ways that angles can be drawn that tells us their measure. So, you use, angle addition is used when an angle is made up of multiple parts, just like segment addition, but instead with angles. Multiple parts. So, first, let's analyze this picture. Anywhere in this problem did it tell me bisect or midpoint? No, so I don't know that those parts are equal. They may look equal, but they're not. So I know I'm going to have to use part plus part equals whole here. However, do they give me an expression or do they give me a value for the whole? What tells us what the whole is equal to? Oh, what does the square
90 degrees.
mean? It means that this whole ABC angle has to be what? 90. That's our whole. It has to equal 90 degrees. So, I have a part, and I have a part, and I have a whole. And I know my equation is part plus part is equal to my whole. So my first part has a value of, and my second part has 7x. Oh gosh, I did it again. I am so sorry. There we go. Equals the whole, which is how much? 90. So now I combine like terms. What is 3x plus 7x? 10x. And then what do I do? By. And I get 9. Is that my answer? Right. It wants the measure. Oh, by the way, that M in front stands for measure. It wants the measure of angle ABD. Which, what is the expression on ABD? 3x. And what did I solve x to be? So 3 times 9 is? So the measure of angle ABD is 27 degrees. All right, so we're going to finish up. We're going to finish up this last example here. What equation are we going to use to help us? Beautiful. So we have part and part. What is our whole? How do you know? Oh, the two angles share the same vertex and their bases form a straight line, meaning that these two angles combine to create a straight angle. Another word that we could use for these two angles is that they're supplementary, or we can also say that they are a linear pair. So these two angles are a linear pair, meaning they add up to 180 degrees. That's our whole. So again, we're going to do part plus part equals our whole. The part in this case, the first part is what?
4x.
Beautiful. Plus the second part, which is 4x plus 40, equals the whole, which we found to be 180. So, what is 4x plus 4x? And 60 plus 40 equals 180. Then what do we do? Subtract 100. And 8x is divide by 8. And what is x? X is 10. Is that our answer? Why not? Right. It says find the measure of angle YAZ. Which the measure of, what is the polynomial on YAZ? 4x plus 40. And our x is what do we solve x to be? 4 times 10 is plus 40. 80 degrees. Any questions? The hardest part about this is remembering that two angles that form a straight line are 180 degrees. All right, one last thing. On the back of your smaller foldable, you'll see this vertical angles. Vertical angles are angles formed by two intersecting lines. So here we have two intersecting lines. They intersect each other at one point. The angles located directly across from each other are called vertical angles. So angles that are across from each other in two intersecting lines are called vertical angles. Now the special thing about vertical angles is they are always congruent. Good. They will always have the exact same measure. So if this top angle is 100, what will the bottom angle be? Good. They are vertical angles across from each other. They are congruent. And if those two angles are 100, what is this left angle? 80. Good. Yeah. Because the 100 and this angle form a straight line, a 180 degree angle, a linear pair. Okay? And then the one across from it is also an 80. So, knowing this, how can I solve for x? Right. We can do what to them? Set them equal. Math, yeah. 3x equals 4x minus 20. Vertical angles are congruent. I can set them equal. Now what do? How? Good. 3 minus 4 is? And then? So x is 20. Knowing x is 20, what does that top angle equal to? So what does that bottom angle have to be? And what is the angle right next to the 60? 120. So the angle across from that is 120. Anytime you have two intersecting lines like this, there are actually only two values that you're going to have because the angles across from each other are congruent. Any questions on vertical angles? All right.